Okay, limiting reagents. Today, we look at limiting reagents can be defined as a chemical reactant. Limiting reagent can be defined. Limiting reagents can be defined as a chemical reactant that limits the amount of product that's formed during a chemical reaction. Limiting reagent can be defined as a chemical reactant that limits the amount of product that is formed during a chemical reaction. Can be defined as a chemical reactant that limits the amount of product that is formed during a chemical reaction. It is usually completely consumed during a chemical reaction. It is usually completely consumed during a chemical reaction. It is usually completely what? Consumed during a chemical reaction. It is usually completely consumed during a chemical reaction. It's usually what? Completely consumed during a chemical reaction. Now, write notes. Note, those reagents or reactants that are left over those reagents or reactants that are left over, once the limiting reagent is completely consumed, those reagents or reactants that are left over, once the limiting reagent is completely consumed, are called excess reagent or reactant. Are called excess reagent or reactants. Are called excess reagent or reactants. Those reagents or reactants that are left over, that are left after the limiting reagent is completely consumed, are called excess reagent or reactants. Now write down steps and procedures in calculating limiting reagent. Steps and procedures in calculating limiting. Steps and procedures. Steps and what? In calculating limiting reagent. Class, what we're trying to say here under limiting reagent is that limiting reagent is the reactant that's first consumed during a chemical reaction. Class, if you have a reaction A plus B to give C, be rest assured that between A and B, one of the reactants will finish first. And once that reactant is finished or is consumed, the reaction will stop, meaning that there will be no more formation of products. Now that reactant that finishes first between A and B is termed the limiting reagent. And that reactant that is left over is termed the excess reagent. So between two reactants in a reaction, one is going to call the limiting reagent and the other will be called the excess reagent. Now, why are we peculiar about limiting reagent? We're not going to study excess reagent, we're going to study limiting reagent. Why? Because the limiting reagent, if you go back to your definition, is one that limits the amount of product that can be formed. The limiting reagent does what? Limits the amount of product that can be what? So how much product can be obtained from a given reaction is determined by this limiting reagent. Hence why we're studying it. Because the person that determines when the reaction will stop holds the key to the reaction. So the reaction can be taking place. But once that person decides that the reaction will stop now, it will stop now. So that person is very important. That's why we say limiting reagent determines the maximum amount of product that can be formed. The maximum amount of product that can be formed. Now, class, how do we determine limiting reagent without carrying out the reaction in the lab? In your exam or you're given a question and you are given that CaCO3 reacts with HCl to give CaCl2 plus H2O plus CO2. Balancing the chemical reaction, we'll put 2 here. Class, apart from carrying out the chemical reaction, there's a step-by-step approach you can use to determine who will finish first without even carrying out the reaction. Class, there are possible questions they can ask you here is, who is determine the limiting reagent? Option A, CaCO3, B, HCl, C, this, D, this. Class, first things first, rule out these 2. Our limiting reagent can never be in the right hand. It's definitely between these 2. So you now have 2. You're not guessing between 2, or you're trying to figure out between 2. Let's not say guessing. So how do we determine this? Who will finish first when you do not carry out the reaction yourself? Plus, there are some laid out steps that can help you determine who will finish first among these two. And that's what we're looking at. Steps and procedures to determine limiting reagent. 1. Steps and procedures in calculating limiting reagent. 1. Find the number of moles of each reactant present. 1. The first step to determine limiting reagent. Find the number of moles of each reactant present. Find the number of moles of each reactant present. Find the number of moles of each reactant present. Find the number of moles of each reactant present. Class, you recall the number of moles is simply what the reacting mass divided by the molar mass. So number of moles is reacting mass divided by the molar. So step 1 is to determine the number of moles of each reactant present. Step 2, are you there? Divide the number of mole of each reactant obtained from step 1. Divide the number of mole of each reactant obtained from step 1. Divide the number of moles of each reactant obtained from step 1. Divide the number of moles of each reactant obtained from step 1 by their stoichiometric coefficient. Divide the number of moles of each reactant obtained from step 1 by their stoichiometric coefficient. Divide the number of moles of each reactant obtained from step 1 by their stoichiometric coefficient. Coefficient. I'll explain. Class, who are the stoichiometric coefficient? If you have a reaction 2A plus 3B to give 4D. Class, stoichiometric coefficient of A here is 2. The numbers before the element is the stoichiometric coefficient of D here is what? And sorry, this should be C, and D is what? 4. So these numbers before the components are termed stoichiometric. Okay, 3 now. 3 is the last step. It's not a long method to determine limiting reagent. 3. The smallest value from step 2 becomes the limiting reagent. 3. The smallest value from step 2 becomes the limiting reagent. The smallest value from step 2 becomes the limiting reagent. The smallest value from step 2 becomes the limiting reagent. The smallest value from step 2 becomes what? First example, let's go class. At high temperature, sulfur combines with iron. At high temperature, sulfur combines with iron. First example. At high temperature, sulfur combines with iron to form brown-black iron 2 sulfide. At high temperature, sulfur combines with iron to form brown-black iron 2 sulfide. At high temperature, sulfur combines with iron to form brown-black iron 2 sulfide. If this light goes off, let me know. I'm not sure if the battery is strong. That's why I'm checking it. If it goes off, let me just be watching it from here. Brown-black iron 2, according to the following equation, Fe plus S to give FeS. Fe plus S to give Fe. At high temperature, iron combines with sulfur to form what? Brown-black iron 2 sulfide. Class, this brown-black iron 2, according to the following. If 7.62 gram of iron, that's Fe, is allowed to react with 8.67 gram of S. If 7.62 gram of Fe is allowed to react with 8.67 gram of S, determine the limiting reagent. determine the limiting reagent. If 7.62 gram of Fe, which is iron, is allowed to react with 8.67 gram of S, determine the limiting. So we are to determine who will finish first or who will be first consumed among these two reactants. Which of these two reactants will be first consumed will be our limiting reagent. And now we have the steps. Let's proceed to determine it. Class, let us take the molar mass of Fe as 56 gram and take the molar mass of sulfur as 32 grams. Let us take the molar mass of Fe ion as 56 gram and sulfur as 32 grams. You know we will need the molar mass, right? Because to determine number of mole is reacting mass divided by molar. Class, I intentionally made this question super simple so that you can really understand. Then as we are going to more examples, as usual, we increase the level of difficulty of the question. Class, if you notice, to make coefficient of these two reactants are 1, 1, right? No more challenge. No more challenge. Yes, gram, yes. Now, class, gram per mole, of course, if you have to be very specific, gram per, that's molar mass of iron, gram per mole, sulfur, gram per, that is per 1 mole of that element, that's the mass. Are we together? Now, class, what's the first step in determining the limiting reagent? Find the number of mole of each. So we're going to find the number of mole of iron. We're going to find the number of mole of iron is reacting mass of iron. What's the reacting mass? 7.62 grams of iron is allowed to react, right? So reacting mass of iron is 7.62. All over molar mass of iron is 56. What's the reacting mass of sulfur? 8.6 divided by molar mass, 30. Plus, if you ask for the specific unit for molar mass, it's gram per mole. If you want to be very, very specific. Gram per, please take note, please take. So number of mole of iron will be 7.62 divided by 56. 0.136 mole. And 8.67 divided by 32. 0.271 mole. So class, the number of mole of iron is 0.136 and number of mole of sulfur is 0.271 mole. Class, the next step, that's we just obey step 1. Find the number of moles of each reactant. Step 2 now says we should divide by the stoichiometric. Class, stoichiometric coefficient of iron here is 1. If there's no number here, it means it's 1. So divide by. This is also what? I intentionally made this question simple. It won't be this simple. Please take note. You will always have 1, 1. Now, class, we're going to have 0.136 divided by 1 is 0.13. And 0.271 divided by 1 is 0.27. Class, after step 1 and 2, the reactant with the least number of mole becomes our limiting. So who is the least number of mole? Between 0.136 and 0.271. 0.136, right? So class, therefore, we've determined that iron will be consumed first during this reaction. Iron will be consumed first during this reaction. And therefore, iron is our limiting reagent. Iron is our what? Limiting reagents. Right now, let's take a more difficult question. As we are going higher, we increase the level of difficulty. Not that it's more difficult though, it's just maybe more stoichiometric coefficients. I think you still get it if you are following the step. It's simple. It's simple. Quickly. It is straightforward, right? What's the limiting reagent in the reaction of 5.0 gram of nitrogen and 5.0 gram of hydrogen? What is the limiting reagent in the reaction of 5.0 gram of nitrogen? What is the limiting reagent in the reaction of 5.0 gram of nitrogen and 5.0 gram of hydrogen? Oh, wow. According to the following reaction, 3H2 plus N2 to give 2NH3. What's the limiting reagent in the reaction of 5.0 gram of nitrogen and 5.0 gram of hydrogen. Class, notice that both hydrogen and nitrogen are 5.0, 5.0. So they have the same mass. Someone would think that they will finish the same time. And you find out that they might not finish the same time, even if they started with the same mass. 5.0 gram of nitrogen and 5.0 gram of hydro. According to the following reaction, what's the limiting? Who will finish first? Who will be first consumed? Which of the following reactants will be first consumed? Class, I think it's right to give you the mass. Nitrogen, you have 14. If you're looking at the atomic mass, or if you're looking at nitrogen as a whole, because nitrogen is diatomic. Nitrogen is what? We're going to say 14 times 2, we have 28 gram. 28 what? The molar mass of 1 mole of nitrogen is 28 gram per. Class, someone like sodium is monoatomic. It's 23 gram. So 1 mole of sodium contains 2 atoms of sodium. 1 mole of sodium contains what? 2 atoms of sodium. But 1 mole of nitrogen contains 2 atoms of nitrogen. So the way you treat sodium and the way you treat nitrogen will be different. So I know normally an atom of nitrogen is 14 atomic mass, right? An atom of nitrogen is what? 14. Atomic mass of 1 atom of nitrogen is what? 14. But 1 mole of nitrogen is not 14. Because 1 mole of nitrogen contains 2 atoms of nitro. That will be 14 times. So if you use 14 as the when you are finding number of moles, and you use 14, number of mole over molar, mass over molar mass, you use 14, you'll be wrong. You should use 20. Be very careful when you're dealing with diatomic elements. Yes, obviously, yes. Because nitrogen is existing 1 here, right? It's not existing N2. Now, so take nitrogen as 14 and take hydrogen as 1. Although let's take hydrogen as 2, sorry. Because actually also 1 mole of hydrogen, it contains 2 atoms of hydrogen. So 1 times 2, 2. 1 mole of hydrogen contains 2 atoms of what? So 1 times 2 is what? 2. Hydrogen is also one of those diatomic elements. Diatomic what? Elements. I keep looking at this mic because once it goes off, anything I'm saying, they will not hear it again. So I'm not sure if I charged it. So I don't know if the battery is strong. That's why I keep looking at it to see if it's not off. Once it goes off, I have to then remove it and just talk normally. If not, anything I'm saying, you'll not even hear it in the video. But so far, it's still on. I said, checking it for me. Once you don't see this green light again, let me know. Class, are we solving already? Apply the just 3 steps, right? It's even 2 steps. The third step is just a confirmation. The one with the least number of mole, right? Oh, you're done already? You're done already? Okay, go ahead, go ahead. Why do you think so? Step 1, class, reacting mass is 5 gram. Reacting mass is 5. So number of mole is mass. Reacting mass 5 gram. Number of mole of hydrogen 5 gram over molar mass of hydrogen is 2. Number of mole of nitrogen. Reacting mass 5 gram again. Molar mass 28 gram per mole. First step said find the number of mole of each reactant. What is 5 divided by 2 is 2.5 mole. And 5 divided by 28 is what? Someone should help us. What's 5 divided by 28? 0.179. So 2.5 mole and 0.179 mole, right? Now divide this 2.5 by this coefficient 3. And divide this 0.179 by 1, right? What is 2.5 divided by 3? 0.83 what? 833 mole. And 0.179 divided by 1 is 0.17. Now the person with the least is the limiting. So it means that nitrogen is obviously the lowest, right? So nitrogen is the limiting reagent class in this reaction. Nitrogen is the limiting reagent. Nitrogen is the limiting reagent. Nitrogen is the limiting reagent. So class, this is how you determine limiting reagent. Let's go to concept of, we're going to look at yield, theoretical yield, and actual yield. Last question. Last question. What department? Class, moving forward, our next subheading is yield, theoretical yield, and actual yield. Yield, theoretical yield, and actual yield, theoretical yield, and actual yield. Subheading yield, theoretical yield, and what? Actual yield. Class, let's start with yield, right? And yield is defined as the maximum amount of specified product obtained at the end of a chemical reaction. Yield is defined as the maximum amount of a specified product obtained at the end of a chemical reaction. Yield is defined as the maximum amount of specified product obtained at the end of a chemical reaction. Yield is defined as the maximum amount of specified product obtained at the end of a chemical reaction. Class, yield is measured in mass. Class, if A plus B gives C, the maximum amount of C formed is called our yield, simples. The maximum amount of C that is called our yield. Maximum amount of specified product obtained at the end of a chemical reaction. Hope it's 200 level you are giving her. Maximum amount of a specified product obtained at the end of a chemical reactions. So class, Na plus B react, the maximum mass of C formed is called our yield. But we have two types of yield, class. We have the theoretical and the actual yield, class. We have two types of yield, the theoretical and the what? Class. One, as the name implies, theory. The other one, actual. Class, if you mix 10 grams of A with 10 grams of B, class, normally, theoretically, maybe you're expecting to get 20 grams of C. Theoretically, based on calculation. Based on what? Calculation. 10 grams of A with 10 grams of B should give 20 grams of C. But class, what happens theoretically and what happens in real life are not usually the same. They don't usually correlate. Class, it's possible that you can take this 10 grams of A and 10 grams of B and react it. Instead of getting 20, you are getting 18 grams. Class, the actual amount of product formed is called the actual yield. But the calculated yield without the experiment being carried out is called the theoretical. So theoretical yield is gotten from calculation, stoichiometric calculation of the reaction. Theoretical yield is gotten from the stoichiometric calculation of the reaction. Normal stoichiometry, if this and this react, this and this will be formed. You never carried out the experiment. It's just calculation. When you not carry out the experiment, a lot of errors can affect your final yield, right? That might not be what you calculated. Are we together? So class, there's difference from what you're expecting and what you actually have. So sometimes we call theoretical yield expected yield. Expected, what you're expecting based on calculation, 10 plus 10 should be 20 now. Theory is theory, you have not done the practical. In practical, a lot of disadvantages could occur. A lot of limitations could occur. All measurements have some degree of uncertainty. So when you not carry out the experiment, you're getting 18. So class, one thing you should also know that the actual yield is usually a bit lesser than the theoretical what? Yield. So you now understand the concept of actual and what? Theoretical. So these are the two types of yield we have, actual and what? But generally, when defining yield, yield is just the maximum amount of product that's obtained at the end of a chemical. That is what we call percentage yield, class. Percentage. You could be asked to calculate the percentage yield. The percentage yield is the actual yield divided by the theoretical yield times 100% over 1. The percentage yield is the actual yield divided by the theoretical yield times 100% all over 1. This is the percentage what? Yield. Actual over theoretical times 100% all over. This is the percentage what? Yield. Don't forget that the actual is usually lesser than the what? Theoretical. So right now, let's define theoretical yield. We've not defined it yet. Theoretical yield is the maximum amount of products. Class, 1 minute. Class, yes. Theoretical yield is the maximum amount of product expected. Theoretical yield is the maximum amount of product expected when all of the limiting reagents are totally consumed. Theoretical yield is the maximum amount of product expected when all of the limiting reagents are totally consumed during a chemical reaction. Theoretical yield is the maximum amount of product expected when all of the limiting reagents are totally consumed during a chemical reaction. Note that theoretical yield is always determined. Theoretical yield is always determined by doing a stoichiometry calculation from the balanced chemical equation. Theoretical yield is always determined by doing a what? Stoichiometry calculation from the balanced chemical equation. Theoretical yield is always determined by doing a what? Stoichiometry calculation from the balanced chemical equation. By doing a stoichiometry calculation from the balanced chemical equation. So class, theoretical yield is obtained by calculation. Actual yield is obtained by actually doing the practical, by actually doing the 10 plus that. It's not getting 20, it's giving me 18. Let's take a question and we'll round up. I know you have physics by 2, right? Let's take one question and we'll round up. You see that. So please do not joke with our Saturday classes. Chemistry will continue on Saturday. We have chemistry on Saturday. We also have math 120 on Saturday's chemistry and math 120 on Saturday. So please don't joke with it. Saturday class. Tomorrow is physics. Tomorrow we have physics. From Monday till Wednesday, we have been doing math so far. Math. So today we decided to do chemistry. Tomorrow we're going to do what? Physics. Then Saturday, tomorrow is Friday, right? Then Saturday we'll take chemistry again. This can continue from here exactly. Chemistry again and math 1. So all those other things are posted math 1. I'll teach them on Saturday. The Saturday class is now by 12, not 11. 12 to 2, 2 to 4. 12 to 2, 2 to... So 12 to 2 is chemistry. 2 to 4 is math 120. Please take note for Saturday. But tomorrow we are meeting by 1:30 p.m. for physics. Tomorrow is 1:30 p.m. for physics. Okay, take this question and we'll go on for our lecture. Given the reaction 4NH3, plus 5O2, given the reaction 4NH3 plus 5O2, given the reaction 4NH3 plus 5O2 to give 4NO plus 6H2O. Given the reaction 4NH3 plus 5O2 to give what? 4NO plus 6H2O. If 3.25 gram of Na3 is allowed to react, if 3.25 gram of Na3 is allowed to react with 3.50 gram of O2, if 3.25 gram of NH3 is allowed to react with 3.50 gram of O2, if 3.25 gram of NH3 is allowed to react with 3.50 gram of O2, A, what is the limiting reagent? A, what is the class? Let's remember something. B, what's the theoretical yield? What's the theoretical yield? What's the what? Of NO. What is the theoretical yield of NO? Yield of what? Why they specify NO? Because in this product side, we have two products, right? So they have to specify which of the products you're looking for. Because yield is maximum amount of product that is formed. So when you have two or more products, they will specify the products that they want you to calculate. They will specify the product that they want you to do what? Calculate. So class, you know why they ask us for limiting reagent? Do you know that limiting reagent determines the maximum amount of product that is formed in a reaction? Because I think I said it on Saturday, or I don't know, or I've said it today, that as soon as that person that finishes first determines the highest product that will be formed. Because once it stops, the product stops being formed, right? Once that limiting reagent stops, finishes, or consumed, the reaction ends and the product stops there too. So where the limiting reagent ends is the highest product that is also formed. So you see why the correlation between limiting reagent and theoretical yield. Class, if they wanted to ask us to find the percentage yield, class, if they wanted us to find the percentage yield, see what they would have done. After asking us to find the theoretical yield, they will tell us that given that when this and this reacted, so and so mass of NO was formed. When this and this reacted, so and so mass of NO was, that mass of NO that is formed, class, that they will tell you is the actual yield. Because in the exam, it's impossible for you to get actual yield. Actual yield must only be gotten during calculation. Sorry, during the experiment, during the main. So it's most likely to be given to you. The one that we are most likely to be calculating for is theoretical, because that one you can calculate for it. So most times they will tell you that given that when 3.25 gram of ammonia reacted with 3.50 gram of oxygen, so and so mass of NO was, calculate the percentage yield. Calculate the what? You will now go and find the theoretical yield and find that the theoretical yield is higher than the actual yield. Class, it should be sure that you are correct. Your theoretical is always higher than your actual, because actual divided by theoretical times 100%. But in this question, you are lucky they didn't even give us to ask us to find the percentage yield. They asked us to find the theoretical yield of NO. But class, we must first determine the limiting reagent. I believe you can do this. Go ahead and do it. Determine the limiting. A says, what is the limiting reagent? A said, what is the limiting reagent? I believe you are solving, class. We have already done limiting reagent. I believe you are solving. It's just to find the number of moles of each reactant. Find the number of moles of each reactant. So reacting mass divided by the molar mass. Reacting mass divided by the molar. Then divide by their coefficient. Divide by their. Class, go ahead. I believe you are solving. I believe you are solving. Go ahead and solve. Go ahead and solve. All right, let's find out the limiting reagent. Following the procedure we gave out. We find the number of moles of each of the reactants. Class, number of mole is mass, reacting mass. So let's find number of mole of ammonia. All over molar mass of ammonia, I know it's 17 because nitrogen is 14. Hydrogen is 1 times 3, 3. 14 plus 3. It is what you used. And number of mole of oxygen is, a reacting mass is 3.50. Molar mass is O2, 16 times 2. This is what you used? Okay, you're on the right track. So give me, what did you have as number when you divided this? 3.25 divided by 17. 0. What? 0.1. What of this? 0.10. Good. Now, I haven't gotten number of mole. Now divide by their coefficient. The coefficient here is 4. Coefficient here is 0.191 divided by 4. 0.048. 0.048. And what's this? 0.02. So who is the smallest? 0.022 is the smallest, right? Hence, oxygens are limiting. So in case you are still confused about this limiting reagent stuff, I think this should clear all confusions now, right? Now we've gotten the limiting reagent, the person that will finish first. It's now time to use that person to determine the mass of NO that will be formed, because the limiting reagent that determines the mass of NO that will be formed. So we're going to use oxygen to determine the mass of NO, because someone question, what is the theoretical yield of NO? Class, what's theoretical yield of NO is something that's asking you what is the mass of NO formed. What is the theoretical yield of NO? It's something that's asking you what is the mass of NO formed. Because theoretical yield is the maximum amount or maximum mass of product that is formed in a chemical reaction. And you get the theoretical yield only from the limiting reagents. So class, let us go ahead and get the mass of NO that will be formed using oxygen. Now we're going to use oxygen because oxygen is a limiting reagent. We're going to say from the balanced chemical equation, we have oxygen is 16, 16 times 2 is 32, 32 times 5 is 80. From the balanced chemical equation, 80 grams of oxygen gave what mass of NO? What's the mass of NO here, class? N is 14, O is 16. 14 plus 16 is 30. 30 times 4 is 120. So give 120 gram of NO, class. This O2, this N. Why is it O2 we're using to get NO? Because O2 is the limiting reagents. You see? 32 times 5 is 160. Sorry, did I say 120? Oxygen is 16. 16 times 2. 32 times 5 is 160. Yes, sorry. I was doing 16 times 5. 8 is 160. You are correct. It's 160. You are. So 160 gram of O2 from the balanced equation, 160 gram of O2 gave 120 gram of NO. Because N is 14, O is 16. 14 plus 16 is 30. But there are 4 of them. So 30 times 4 is 1. From the balanced equation, 160 gram of O2 gave 120 gram of N. Now, what mass of O2 is available? 3.50 reacted, right? So 3.50 gram, we give what? We don't know. We'll call it what? Whatever we get as X is the mass of NO formed. Is the maximum mass of NO formed. And it's also a theoretical. Because theoretical, it is the maximum mass of product that is obtained during a chemical reaction. We then cross 160 times X is 160. 3.50 times 120. Making X squared to the formula, divide both sides by 160. 2.625. X is 2.625 gram. Class, these are theoretical yield. These are theoretical yield. These are what? Theoretical yield. An industrial chemist, another question. Right, let's take a question that will require you to get both theoretical yield and percentage yield. Are we there? An industrial chemist carried out a reaction by reacting. An industrial chemist carried out a reaction by reacting. An industrial chemist carried out a reaction by reacting 75.0 gram of P4. An industrial chemist carried out a reaction by reacting 75.0 gram of P4 with excess chlorine gas. With excess chlorine gas to produce 110 gram of PCl3. To produce 110 gram of PCl3. To produce 110 gram of PCl3. According to the following equation, P4 plus 6Cl2 to give 4 PCl3. I'll come again in case I was too fast. An industrial chemist carried out a reaction by reacting 75.0 gram of P4 with excess chlorine gas, Class, by saying with excess chlorine gas, they have indirectly told you that chlorine is the excess reagent, and therefore P4 is the limiting. So this question does not require you to determine the limiting reagent again. With excess chlorine gas means that this guy is the excess reagent. Because class, once one reactant has determined as excess, the other person is limiting, right? Because the opposite of excess reagent is limiting reagent. Good. With excess chlorine gas, to produce 110 grams of PCl3, to produce 110 grams of PCl, according to the following equation, P4 plus 6Cl2 to give 4 PCl3. A, what is the theoretical yield? And B, what's the percentage yield? A, what is the theoretical yield? A, what is the what? Theoretical yield. And B, calculate the percentage yield. A, what is the theoretical yield? B, calculate the percentage yield. Are we there? A, what is the theoretical yield? B, calculate the percentage. Ask him, you're far behind. You two are not there. I called it twice now. I said to produce 110 gram of PCl3. To produce 110 gram of PCl. To produce what? 110 gram of PCl. When everybody is done with all their practicals, remind me so that we can organize a serious shortcut class for mathematics for exam purpose. Shortcut class. By then you should have gotten your calculators so we can work. We can work for exam purpose. Yes. Now, you want to try this? Yeah, go ahead. Okay, time for your practical, Abi. Good luck. See you tomorrow. Okay, let's look up. You see? 4.5. They say, what is the theoretical yield? 75.0 gram of P4. 75 point. So the reacting mass of P4 is 75.0. Class. If you notice, they did not specify because we have only one product here. So this is clearly the person we are looking for. If there were two products, they would have said, what is theoretical yield of so and so. But they just said theoretical yield because it's only one product that's there. So clearly, class, it's P4 that determines the maximum amount of PCl3 that will be formed. This is the limiting reagent. From the balance equation, P, what is P? P is 31. Atomic mass of phosphorus 30. So 31 times 4 should give you 124, right? So from the balance equation, 124 grams of phosphorus. From the balance equation, 124 grams of P4 gave what mass of PCl3? P is 31. Cl is 35.5. 35.5 times 3 is what? 106.5. So 31 plus 106.5, everything multiplied by 4 because of this 4, right? What will you have? What is total molar mass for PCl3? P is 31, Cl is 35.5, but we have 3, right? So 35.5 times 3, add it to this 31, then multiply everything by 4. You get 550. Really? 550 gram of PCl3. So 124 gram of P4 produce 550 gram of PCl3. Now, what mass of P4 is available now? 75.0 gram of P4. We give what? X. We don't. Let X represent the unknown. Let X represent the. Then we'll go ahead to cross. So that 124 times X is 124X equals 75.0 times 550. Now divide both sides by 1, 2. So we're going to say 75.0 multiplied by 550 divided by 1, 2, 4. Will give us the theoretical. Will give us the what? 3 what? 332.7 gram is our theoretical yield. But class, B said we should find the percentage yield. To calculate percentage yield, you need actual divided by theoretical. We have calculated theoretical. Now, is there a way we can get the actual? Yes. Class, if you notice on the question said to give 100, produce 110 gram, right? So 110 gram of this guy was produced when the reaction was carried out. But class, look at calculation, theory. From the theory, without carrying out the experiment, you should have 332.7. Did I tell you that the theoretical yield should be bigger than your actual yield? Can see? From the theory, from theoretic calculation, it's 332.7 grams that should be produced from 75 grams of P4. We should have 332.7 grams of this. But class, when they carried out the experiment, actually, they did not have anything close to this. They got 110 grams based on the question, what they gave us in the question. So our percentage yield, therefore, our percentage, or the B part question, calculate the percentage. Our percentage yield is actual. What is our actual? 110. All over theoretical, 332 points times 100%. So someone should do the math. Who has done the math already? 110 times 100 divided by 332. 3.1 approximately. So class, you will now find out that our percentage yield is 33.1%. Our percentage yield is 33.1%. Our percentage yield is 33.1%. Class, did I tell you that your actual yield will be given to you? You don't need to calculate it, right? There's a particular question they brought in the exam that there's only one condition where you can still calculate your actual yields. Your actual yield should be something that is when you carry out the experiment actually, that you get the value. You can't calculate on the board, right? But actually, class, if you are given the percentage yields, if you are given the percentage, class, if you have percentage yield and you have theoretical yield, can't you get actual? Without carrying out the experiment, you can still calculate for actual. Let's take this question down. Let's take this question down. This is from your past question, actually. If the percentage yield from the reaction, and this came out 1920 or 2021 in the past question. If the percentage yield from the reaction PCl3, if the percentage yield from the reaction PCl3 plus Cl2 to give PCl5, if the percentage yield from the reaction PCl3 plus Cl2 to give PCl5 is 83.2%, is what? 83.2. So see, they're giving you the percentage yield already. I'll come again. If the percentage yield from the reaction PCl3 plus Cl2 to give PCl, if the percentage yield is what? 83.2%. What mass of PCl5, continue writing, what mass of PCl5 is expected from the reaction? What mass of PCl5 is expected from the reaction of 200 grams of chlorine? What mass of PCl5 is expected from the reaction of 200 grams of chlorine? If chlorine is the limiting reagent, what mass of PCl5 is expected from the reaction? What mass of PCl5 is expected from the reaction of 200 grams of chlorine? If chlorine is the limiting reagent. If chlorine is the what? Limiting. So class, you see that some of these questions, they have already given us who is the limiting reagent. They have already given us who is the limiting reagent. All right, now the question said, if 200 gram of chlorine is 200 gram of chlorine is the limiting reagent, class, let us find what mass of PCl5 will be obtained from 200 gram of chlorine, since we know that chlorine is a limiting reagent. But first things first, we need to find from the balanced equation what mass of chlorine gave what mass of PCl5. From the balanced equation, chlorine is 35.5, but we have two atoms. 35.5 times 2 is 71 gram of chlorine. From the balanced equation, we give what mass of PCl5? P is 31 plus chlorine is 35.5, but 5 of them times. What is the mass, total mass of PCl5, please? 200 and 208.5. After doing this, right? 208.5 gram. So from the balanced equation, 71 gram of chlorine gave 208.5 gram of PCl5. Now what of 200 gram of chlorine? What of 200 gram of, what mass of PCl5 will be formed? We don't know, we'll call it X. Whatever we get here now is our theoretical yield. Whatever we get here now is our theoretical yield. We're going to cross multiply. So 71 times X, 71X equals to 200 times 208.5. Making X formula, divide both sides by 70. 71 cancels 71. You have 200 times 208.5 divided by 71. 200 times 208.5 divided by 70. 587.32 gram. Class, this is theoretical yield. This is theoretical yield. Now, what's the percentage yield? Percentage is 3.2%. You now say 3.2%, percentage yield must be equal to actual over theoretical. Class, you don't need to put times 100% in this. Percentage is ready here. You will just say 3.2% divided by 100, right? Because 3.2% means a 3.2 divided by what? So if you have already said divided by 100, you don't need to write times 100 here again. It's when you are solving for percentage that you put times 100. But when you are using percentage to solve, don't put times 100 after here again. We have our theoretical yield here as 587.32. We can now find our actual yield. As usual, if we are correct, our actual yield should be smaller than our theoretical yield if we are correct. So we'll cross 100 times A is 100A equal to 3.2 times 587.3 divide both side by 3.2 multiplied by 587.32 divided by 100 will give you what? 488.65 gram. So you can see our actual yield can still be calculated. So it's not in all cases that will say that they actually cannot calculate. They must actually carry out the experiment. It depends on the context of the question. If you have been given percentage yield and you have theory, you can get actual. You can get actual yield. I get 71. Chlorine is 35.5. And Cl is occurring twice. So 35.5 times 2 gives you 71. Class, we are done with this aspect. The next aspect we want to look at is atomic structure. Atomic structure. So most 100 level science are not reading. And there are some questions they will ask you. There are some wicked questions they can ask you in between your textbook. That some people will not open their text before they enter the exam. In between some, especially chemistry. There are some things that are inside your textbook that you're wondering how. Write down atomic structure, atomic class. Write down subatomic particles discovery. Subatomic particles discovery. Subatomic particles what? Discovery. So topic should be atomic structure. Subatomic particles discovery. Atomic structure, subatomic particles discovery. Class, we are aware that atoms can be divided into protons, neutrons, and electrons. And we also have the nucleus of the atom, the nucleus of the class. The nucleus of the atom is what contains the proton and the neutron. It's deep within the atomic structure. You find the nucleus of the, is the functional unit of the atom is the nucleus. The electrons orbit round. They go around the orbitals, atomic shells, atomic walls. But the proton and neutron are deep within. Now write down. Let's start with electrons. Write down electrons. Electrons, discovered by J.J. Thomson, the year 1897. Note that year and who discovered it. If you check your past, you see where they will ask some of those, just in between lines question in your chemistry. Electrons, discovered by J.J. Thomson in the year 1897, using a cathode ray tube experiment. Using a what? Cathode ray tube experiment. Cathode ray tube experiment. Electrons, discovered by what? J.J. Thomson in the year 1897. In the year 1897. Using the cathode ray tube experiment. Class, he also further determined the charge to mass ratio of an electron. If you ask, dash determine the charge to mass ratio of an electron is J.J. Thomson. He also determined what? The charge to mass ratio of an electron to be 1.76 times 10 raised to power 8 coulomb per gram. Coulomb per. The charge to mass ratio of an electron was discovered by J.J. Thomson. And he discovered it to be what? 1.76 times 10 raised to power 8 coulomb per gram. 1.76 times 10 raised to power 8 coulomb per gram. Write down Robert Millikan. In the year 1909, Robert Millikan in the year 1909 determined the magnitude of the charge of an electron. So we started with electron, right? All scientists that have to do with anything about electron, we are mentioning them. We have Sir J.J. Thomson discovered electrons using the cathode ray experiment, right? Also helped determine charge to mass ratio of the electron. Now, Robert Millikan, we call him R.A. Millikan. Robert A. Millikan, that's R.A. Millikan, in 1909, determined the magnitude of the charge of an electron and the mass. He determined the magnitude of an electron and the mass to be exactly, he determined the magnitude of an electron and the mass to be exactly 1 all over 1840, the mass of the hydrogen atom. To be exactly 1 all over 1840, 1 all over 1840, the mass of an hydrogen atom. He determined the magnitude of the charge on an electron. Class, J.J. Thomson determined the charge to mass ratio. He did not determine the magnitude of the charge. This can be very confusing. Take note. Because the understanding of this can help in what you choose. If you write J.J. Thomson or R.A. Millikan, they are both talking about charge of electron. But one person just gave us the charge to mass ratio as 1.76. This is J.J. But R.A. Millikan helps us determine the magnitude of the charge on an electron. And the mass to be exactly 1 all over 1840, the mass of an hydrogen atom, Class, it was R.A. Millikan that helps us to find the charge of an electron to be, the charge on an electron is to be 1.602 times 10 raised to power minus 19 coulomb. You know that the charge of an electron is a constant. It was R.A. Millikan that determined the magnitude of the charge of an electron. He determined it to be what? 1.602 times 10 raised to power what? Minus 19 coulomb. Class, the mass of an electron is a constant. And the mass of an electron to get the mass of an electron, we're going to say this charge all over the charge to mass ratio. Charge to mass ratio. What's the charge? 1.602 times 10 raised to power minus 19. And what is the charge to mass ratio? 1.76 times 10 raised to power 8. After doing the math, you're going to have 9.10 times 10 raised to power 28 gram. Class, this is the mass of an electron. 9.10 times 10 raised to power 28 gram is the mass of an electron. Class, the mass of an electron is a constant. The mass of an electron is a constant. Class, that is that for electrons. Let's go to protons. Let's go to what? Protons. These are theoretical things that it's not formula, it's not calculation, it's something you just need to know. That if they ask you dash in the exam, you might be second guessing yourself. What is that? Is it a Rutherford? Is it Rutherford? Some of you know all the scientists' name, but you don't know who did what. You know that there's Rutherford, you know that there's Millikan, you know that there's J.J. Thomson. But you don't know who discovered what and when and how. You just know them. It's scattered, but you don't now. We're arranging them for exam purpose for you. Now, protons. Let's look at protons. Protons was discovered by Eugene Goldstein. We call him E. Goldstein. E what? But this E stands for Eugene Goldstein. In the year 1886. But Thomson put both proton and electron together. Thomson, that's J.J. Thomson. Thomson put both proton and what? Electrons together. Put both proton and electrons together and propose the plum-pudding model of the atom. And propose the plum-pudding model of the model of the atom. So Eugene Goldstein discovered protons, yes, fine. But Thomson put both proton and electrons together and proposed the plum-pudding model of the atom. Let's go to neutrons. Neutrons was discovered by James Chadwick. Discovered by what, James? In the year 1932. Neutrons discovered by James Chadwick in the year 1932. Now, nucleus. Who discovered nucleus? Don't confuse neutron with nucleus. The three subatomic particles are proton, neutron, and electron. But the proton and the neutron are embedded deep within the what? Nucleus of the atom. The nucleus is the functional unit of the atom. It's deep within the nucleus. Now, class, but someone discovered nucleus. Class, Rutherford discovered nucleus. Rutherford. Ernst Rutherford in the year 1911 using the famous gold foil experiments. E. Rutherford. E what? But that E stands for Ernst. In the year 1911, the famous gold foil experiments. Ernst Rutherford, using the gold foil experiment, determined the what? The nucleus. Yes, Ernst Rutherford. Write down atomic spectrum of hydrogen. Atomic spectrum of hydrogen. Atomic spectrum of what? Hydrogen. The spectrum of hydrogen can be obtained, subheading atomic spectrum of hydrogen. The spectrum of hydrogen can be obtained by passing an electric discharge. The spectrum of hydrogen can be obtained by passing an electric discharge current through the hydrogen gas. The spectrum of hydrogen can be obtained by passing an electric discharge current through the hydrogen gas. Taken in the discharge tube under low pressure. Taken in the discharge tube under low pressure. I'll come again. The spectrum of hydrogen atom can be obtained. The spectrum of hydrogen atom can be obtained by passing an electric discharge, current. By passing an electric discharge current through the hydrogen gas, taken in the discharge tube under low pressure. Taken in the discharge tube under low pressure. The spectrum consists of large number of lines appearing in different wavelengths. The spectrum consists of large number of lines appearing in different wavelengths. The spectrum consists of large number of lights appearing in different wavelengths. Yeah, lights, yes. The spectrum consists of large number of lines, not lights, lines, L-I-N-E-S. The spectrum consists of large number of lines appearing in different wavelengths. And therefore, they are called line spectrum. Therefore, they are called line spectrum. Line spectrum. L-I-N-E. Line spectrum. Line spectrum. Class, the well-known fact, don't write this one down, listen. It's a well-known fact that when white light is passed through a glass prism, this is what we call dispersion of light, right? Into its component colors with different wavelengths, different velocities. We are going to have what we call the Roy wave, right? Different red light, orange light, yellow light, green light, blue light, indigo and what? Different wavelengths. This is the same thing that happens in the atomic spectrum of hydrogen. Now, class, the line spectrum is formed. Now, right, and in order to calculate the wavelength of these lines, a general equation was developed. In order to determine the wavelength, in order to calculate the wavelength of these lines, a general equation was developed. In order to what? Calculate the wavelength of these lines. Class, the line spectrum. In order to calculate the wavelength of these lines, a general equation was developed called the Rydberg's equation. A general equation was developed called the Rydberg equation. A general equation was developed called the Rydberg on the board. Rydberg equation. A general equation was developed called the Rydberg equation, where you have 1 all over lambda equals to RH into bracket 1 all over N1 square minus 1 all over N2 square. The Rydberg's equation, where RH represents what? Rydberg's constant. RH represents the Rydberg constant. And we have 1.09677 times 10 raised to power 7 per meter. Class, this is the value of the Rydberg's constant. Class, we said that the hydrogen spectrum consists of different series of lines with different wavelengths. If you go back to your note, where we say hydrogen, spectrum of hydrogen. The hydrogen spectrum consists of different series of, check the last part of the note. The hydrogen spectrum consists of different series of lines with different wavelengths. Now, Rydberg's equation helps us to determine the wavelength of each of those lines. For class, we have different series of hydrogen spectrum. What I want to introduce you to next is the different series of hydrogen spectrum. We have the Balmer series, we have the Paschen series, we have the Lehman series. We are going to the different series of the what? Hydrogen spectrum of lines. So write down, class, because in this formula, we have N1 and we have N2. N1 and N2 are positive integers. N1 are what? Are positive what? Integers. Let's look at this series now. We have different series for the hydrogen spectrum. And class, for each of these series, our N1 and N2 are different. We have the Lehman series, Balmer series, Paschen series, Bracket series, and the P-Fond series. Lehman series, Balmer series, Paschen series, Bracket series, P-Fond series. And each of these series have their N1 represents the lowest level of the lines. For Lehman series, N1 is 1. For the Balmer series, N1 is 2. We have 3. We have 4. We have 5. Are we together? For the Lehman series, N1 is 1. For the Balmer series, N1 is 2. For the Paschen series, N1 is 3 of hydrogen spectrum. For Bracket series, N1 is 4. For P-Fond series, N1 is 5. Now, class, N2. So, class, N1 means the first line. The first what? So, N1 for the first line for Lehman series is 1. N1 for the first line for Balmer series is 2. N1 for the first line for Paschen series is 3. N1 for the first line of Bracket series is 4. And N1 for the first line of P-Fond series is what? Is 5. Now, class, if they told you that you should find the wavelength for the Balmer series for the third line, for the what? We're now going to have the second line will be 2, third line will be 3, fourth line will be what? If it's Lehman series. If it's Balmer series, second line will be 3, 4, 5, because the first line is already 2. Paschen series, you have 4, 5, 6. Bracket series, you have 5, 6. P-Fond series, you have 6, 7, 8. We'll take questions and you see for yourself. N1 is the first line, is the ground level. Just like when you have energy levels. We have the lowest energy level and the highest energy level. So the number of lines in the hydrogen spectrum. This N1 represents the first line in the spectrum. But we have different series of this hydrogen spectrum. We have the Lehman series, the Balmer series, the Paschen series, the bracket, and the P-fond. For the Lehman series, N1, the first line, is we represent as 1. Remember that N1 and N2 must be positive integers. For the Balmer series, N1 is 2. Where you understand this when we start taking questions, you will see how it's applicable. What's the wavelength? What's the wavelength of the fourth line in the Balmer series of hydrogen atom? What's the wavelength of the fourth line in the Balmer series of hydrogen atom? What's the wavelength of the what? Fourth line in the what? Balmer series of hydrogen atom. What's the wavelength of the fourth line in the Balmer series of hydrogen atom? Class, please look up again. Let me explain this one more time. I think I may have explained it wrongly. Look up. Class, in the fourth line. Now, this is the ground level. We don't even start counting. This is not even the first line. This is just the lowest ground level. So the first line, this is Balmer series. So N1 is 2. Look, I want to use this formula. What is the wavelength? It's the best equation. Anytime they say, what is the wavelength in the Balmer series or someone series of an hydrogen atom? This lambda, this symbol stands for wave. So you're looking for this, right? But this guy is a constant. Now, this N1 and N2 is going to be the issue. Because they mentioned Balmer series. Balmer, your N1 is 2. Your N1 is what? But your N2, because they said the fourth line. Because actually, this is the first line, second line, third line. The fourth line is 6. So my N2 is 6. My N2 is what? This is how you calculate your N2. If they said the first line, what's the wavelength of the first line of the Balmer series? The first line is this 3. So my N2 will be 3. So the number of lines they ask you to find determines what your N2 will. If they say what's the wavelength of the second line in the Balmer series, N2 will be what? But N1 does not ever change, no matter the line. So N1 now is 2. This question said the fourth line. N1 is what? 2. The fourth line, you start counting this first line, second line, third line, fourth. So my N2 is 6. My N2 is what? 6. So this will be 1 over lambda. This is what you're looking for wavelength. Equals to RH into bracket 1 all over 2 all square. 1 over 2 all minus 1 all over what? 6 all square. If they say what's the wavelength of the third line in the bracket series? Third line in the bracket. What's the wavelength of the third line in the bracket series? In the bracket series, what's your N1? For N1 does not change. It's 4, right? Now, what's the third line in the bracket? What will be the N2? Third line in the bracket series. Third line. First line is 5. Second line is 6. Third line is... So my N2 is what? Class, in this reverse equation, the most difficult thing to find is N1 and N2. This guy is already a constant. If you can get your N1 and N2 right, this guy is a constant. It doesn't change. Then you've gotten your wavelength. You've gotten your wave. So understanding how to figure out N1 and N2, and N1 is even simple. N1 does not change. N1 for Lehman is always 1, no matter the number of lines they're asking you. For Balmer is 2, Paschen is 3, bracket is 4, P-fond is what? This one does not change. So we're now going to say, to answer this question now, we have ascertained that our fourth line is 6, right? So N1, for this question, they asked us to find this Balmer series. N1 is 2, and N2 is what? 6. Is what? 6 for Balmer, the fourth line. The fourth, first line, second line, third line, fourth. So N2 is 6. Let's now apply to get the wave length. So the wavelength, this symbol for wavelength is called lambda. It's called lambda. The wavelength, 1 all over lambda, is equal to RH. What's RH? 1.09677. Now, don't worry, they will give you this in the exam. Class, at the top of every of your Chem 130 exam will be all the parameters you use to solve. Chem 130 is a course that is very generous with their constants and the things. You don't even need to cram too many of those things. They will give. Check your past question. You see at the top, they always give different parameters first before you now start giving the questions. So you see Rydberg's constant, you see everything you will need to solve. ID gas constant R. No, we have two gas constants. When we get to a gas equation, I'll teach you how to use the ID gas equation and what gas constant to use per time. When do you use 0.0821 and when do you use 8.314? Now, class, RH is 1.09677 times 10 raised per 7 into bracket 1 over, what's my N1? 2 square. 2 square is what? 4, right? Minus 1 all over N2 square. What's N2? 6 square is 30. Let's find the LCM. The LCM here is 36. 36 in 4, 9. 36, 36. 9 minus 1, 8 over 4 can go here 2. 4 can go here. 9 times 4, 36, right? So 2 over 9. So we are left with 1 over lambda equals to 1.09677 times 10 raised to power 7. Everything inside this bracket is 2 over. What is 2 divided by 9? Let's get it in decimal. 2 divided by 9. 2 divided by 9. Someone should help me now, please. 2 divided by 9. 0.222. 0.222. Now, 0.222 times 1.09677. Don't put times 10 raised per 7 here. Just 0.222 times 1.09677. One over. That's 1.09677. 1.0, please check it again one more time. 1.09677 times 0.222. 1.09677 times 0.222. 0.2434 times 10 raised to power. Let's make wavelength. So if 1 over wavelength is this, means that wavelength is 1 over this. 1 over 0.2434 times 10 raised to power. First of all, 10 raised to power 7 will come up and come 10 raised to minus 7. So just do 1 divided by 0.24234. What is 1 divided by 0.2434 alone? Don't include 10 raised to power 7. 1 divided by 0.2434. Because 10 raised to power 7 will come up and become minus on its own. What is 1 divided by 0.2434? 4.1 times 10 raised to power minus 7 meter. Class, this is the wavelength of the fourth line. This is the wavelength of the fourth line of the what? Balmer series. What's the wavelength and frequency of the third line in the Paschen series of hydrogen atom? What's the wavelength and frequency of the third line? What's the wavelength and frequency of the third line in the Paschen series of hydrogen atom? What's the wavelength and frequency of the third line in the Paschen series of hydrogen atom? What's the wavelength and frequency of the third line in the Paschen series of hydrogen atom? I hope you still have that table in your book. What's N1 for the Paschen series? 3, right? So now the third line will be what? If N1 is 3, third line will be, N2 will be what? 6, right? 4, 5, 6. Third line is what? 6. N1 square, N2. Wavelength and frequency. First get the wavelength. I'll teach you how to get the frequency. Solve, solve, solve. I want to be sure that you know it. I don't want to be too fast to solve. So class, to get your frequency, you're going to say your velocity all over wavelength. Because to get frequency, say velocity equals to frequency times wavelength lambda. Class, velocity equals frequency times wave. So make frequency straight out of the frequency now equals to velocity divided by wave. And the velocity, we're going to use velocity of light, since we are dealing with line spectra and atomic spectra. And the velocity of light is a constant, 3 times 10 raised by 8. The velocity of light is a constant, 3 times 10 raised by 8. You divide it by the wavelength you got to get the frequency. What do you have as a frequency now? After doing the math? 3 times 10 raised by 8 divided by our wavelength, 1.095 times 10 raised by minus 6. You see? Your wavelength is different. Class, 1 all over lambda, let's solve together, equals to, what's RH? 1.09 what? Times 10 raised by minus 7. Times 10 raised by what? Times 10 raised by 7, sorry. Into bracket 1 all over, what's N1? 3 square. 3 square is 6 square is 30. LCM is 36. 36 in 9, 4. 3 over 1 over 12, right? 0. Point what? So 1.09677 times 10 raised per 7 times 0. Point what? 083. Now what is 0.083 times 1.09677? 0.091. So 1 over lambda equals to 0.091 times 10 raised per 7, right? Make lambda square the formula 1 all over 0.091 times 10 raised per. Let 10 raised per 7 come up. Just do 1 divided by this, right? What will you have? 10.98. 1 divided by 0.091. 10.989 times 10 raised per minus. Now, when the decimal comes one place back, it becomes minus. It becomes what? So 1.098 times 10 raised per minus 6. 1.098 times 10 raised per minus 6. So actually, it should have been 1.098. 1.098. Maybe approximated anyhow, but times 10 raised per minus 6. Okay. Two of you approximate yourself. Now let's continue. Because when 7 comes up, it takes a negative sign in mathematics. We have said 1 divided by this. This 7 will come up and become minus. Even if you go up, you'll be minus 2. So this is it. Are we together? So we have this. Now this guy divided by this guy will give you our frequency now, right? Our frequency is speed of light divided by wavelength. Speed of light divided by what? Wavelength. That will give us what now? Yes, a constant. 3 times 10 raised by 8 meters per second is a constant. So what's this? Someone should help me with the answer. 1 divided by what? This. But not without your WAEC calculator. You go and change it first. Because that calculator cannot give it your junior one. Buy another one. What you do? This guy has to be in a bracket. It has to be in a what? Bracket. The young shall go. The young shall. This guy cannot do shortcuts. Get good. Or you're still writing WAEC or something. Bro, give it out. Give it out. I know you paid your WAEC fee and you're still paying you. Understand? But give it out. Then you give out things. More will come. Understand? How you using WAEC in year 1? Get Casio calculator, a strong science calculator. So we can teach you shortcut. Now, this divided by this, I want to give me the frequency first. Nobody solve. Yes, 2 points. Yes. 14 sharp hertz. Class, this is the unit for frequency hertz. H, Z, H, Z. H what?